Welcome back for day 6. Today, our goal, given a polynomial, you will be able to factor completely. All right, so let's go ahead and take a look. So our day 6 notes, factor completely. Now, we have been factoring now for the last 6 days. But now we're going to factor completely. So when you do something completely, you're going to do it all the way. And remember, when you do things all the way, sometimes you're going to have to do them more than once. So when you factor completely, that means you're going to have to factor twice. So you're going to have to factor more than once today. Okay, so here are the steps that we're always going to follow through. So to factor completely, you're going to search for a greatest common factor. If you find one, factor it out. Examine what remains. Look for a trinomial or a binomial which you can factor. Express the answer as a product of all the factors you have found. Okay, so what these steps are doing is they're going through the list that we've been using over the last few days. So remember, you always try GCF first, then DOPS, then trinomial, and if none of those will work, you use grouping. Okay, so let's take a look now at our first example here. Factor completely. So we're going to factor twice. So the first type of factoring we always try is GCF. So let's take a look. 5x squared minus 45. So is there a GCF? Well, yes, there is. Your GCF, 5, is going to go into both of those. So I'm going to go 5 parentheses, and now I divide both of these by 5. The 5's cancel, and we get x squared minus, here we're going to get 9. Now, we factored once, but we were told to factor completely. All right, so that means we have to look inside of the parentheses. Can I factor this again? Well, we already used GCF, so now we're going to look. Can we use DOPS? X squared minus 9, they are both perfect squares. It is difference, so yes, we can use DOPS. So I'm going to go my 2 sets of parentheses. One gets a plus, one gets a minus. Now we're going to go back up and we're going to take the square root of both of our terms. So the square root of x squared is x and x, and the square root of 9 is 3 and 3. Okay, now we factored twice, but we're missing one of our factors. I have to take this 5 and I have to bring it straight down because all of these together is my final answer. And we've done it. Okay, let's go ahead now and let's take a look at number 2. Again, your directions, factor completely. So they're telling you you're going to have to factor more than once. So the first type of factoring we're going to try is GCF. So let's take a look here. Do they have a number in common? Yep, so all 3 of them can be divided by 4. Do they have a variable in common? Yes, they have an x in common, so that's going to be your GCF. So now we're going to go ahead and divide it out. So 4x, and then I'm going to put a set of parentheses and divide everything by 4x. Okay, and when we do that, the 4's are going to cancel, and they get 1, and then we're going to get x to the 4 minus 24 divided by 4 is going to give us a 6. X to the 3rd divided by x to the 1 gives us x squared. And then keep the minus. 28 divided by 4 is 7. Okay, but remember, we're factoring completely, so now we have to factor again. We already used GCF, so now we can try DOPS, but it's not a binomial, so we can't use difference of perfect squares. So now we're going to try trinomial. So this is a trinomial because the number in front of the x to the 4 is a 1. So we're going to go with 2 sets of parentheses. We take the square root of x to the 4, and we get x squared and x squared. Now we need to think of 2 numbers that multiply to -7 and add to -6. So if they multiply to a negative, one's going to be a positive, one's a negative. And let's see, what are the only 2 numbers that multiply to 7? 7 and 1, but if they multiply to a -6, the 7 is negative, the 1 is positive. So now we've done trinomial, we still have to bring that GCF down, and we get 4x in the front. And you have just factored completely. All right, let's try one more, and then I'm going to have you try a few of these on your own. So let's take a look at number 3. So again, we want to factor completely. So the first type of factoring that we're going to try is GCF. So let's take a look. Do these have a GCF? Well, I see that 4 will go into both. They have, well, this is x to the 1, x to the 3, so they'll have an x in common. And they both have y squared, so y squared. So we're going to put that on the outside. And then we get one set of parentheses, and we're going to divide a 4xy squared and put it on the outside. So here, 4 divided by 4 is 1. X to the third divided by x is going to give us an x squared, and the y squareds are going to cancel. Minus 36 divided by 4 is 9. Here the x's cancel, the y squared cancel, so we get just 9. Okay, now remember, we're factoring completely, so now we have to factor one more time. So look inside your parentheses. Can I use difference of perfect squares? Yes, we can. They're both perfect squares, and we have subtraction. So I have my 2 sets of parentheses. One gets a plus, one gets a minus. We take the square root of x squared, the square root of 9. So we get x, the square root of 9 is 3, and we bring your GCF down and we put it in the front. And you now have your final answer. All right, let's go ahead now, and I'd like you to try number 4 on your own. So remember, you're factoring completely, so you're going to factor twice. Go ahead, pause the video, and input your solution. All right, let's go ahead and take a look. So did you get a GCF of 2x? So you get 2x and then a trinomial. And then did you factor your trinomial to get a final answer of 2x parentheses x plus 5, x minus 3. Nicely done. All right, let's go down then and take a look at number 5. So again, we are told to factor completely. So the first thing you have to do is factor using GCF, and then factor one more time. So go ahead, give it a try, and then input your solution. All right, let's go ahead and double check. So did you use a GCF of 5 and then difference of perfect squares? So you get 5 parentheses x plus, 5 plus x to the third, and then 5 minus x to the third. All right, so let's go ahead. We've got one more left. So everybody take a look at number 6. Go ahead, factor completely. All right, let's take a look. Did you get a GCF of 3? And then you had a trinomial factor using trinomial factoring to get 3, n plus 6, n minus 3. Nice job, everyone. Have a great night.